Here we are going to learn about structured query language. SQL, which stands for Structured Query Language, is a powerful tool used in database management. It allows us to interact with relational databases to retrieve, manipulate, and manage data efficiently. SQL plays a crucial role in querying databases, enabling us to extract specific information using select statements. With its ability to perform joins, filters, and aggregations, SQL provides a versatile way to process and analyze data. Whether it's organizing data in tables, performing data manipulations, or working with functions or calculations, SQL serves as a fundamental language for data professionals and developers alike. SQL revolves around several key concepts that are essential to understanding its capabilities. Tables. Data in a relational database is organized into tables which consist of rows and columns. Each row represents a record, while columns represent attributes or fields. Queries. SQL allows us to perform queries, which are instructions to retrieve specific data from the database. The most common query is the select statement. Joins. To combine data from multiple tables, SQL employs join operations. This enables us to access related information from different parts of the database. Filters. The where clause in SQL lets us filter data based on specific conditions, enabling us to extract only the information we need. Aggregations. SQL provides functions like sum, count, average, min, and max, which allow us to perform calculations on groups of data, providing insights into the data's overall characteristics. Understanding these fundamental concepts will pave the way for leveraging SQL to interact with the databases effectively and gain valuable insights from the stored data. SQL syntax serves as the foundation for interacting with the databases. The primary elements of SQL queries include SQL statement. The select statement is the core of SQL queries. It allows us to specify which columns we want to retrieve from a table. From clause. The from clause identifies the table or tables from which we want to retrieve data. Where clause. The where clause is used to filter data based on specific conditions. It allows us to retrieve only the rows that meet certain criteria. Order by clause. The order by clause sorts the results set based on specified columns either in ascending or descending order. Using these fundamental elements, we can construct powerful queries to extract precisely the data we need from the database. The select statement in combination with other clauses forms the backbone of SQL's data retrieval capabilities, making it an indispensable tool for data analysts, developers, and anyone involved in working with databases. SQL enables us to manipulate data within the database using three fundamental operations. First is insert into. With the insert into statement, we can add new records or rows to a table. This operation is essential for inserting fresh data into the database. Update. The update statement allows us to modify existing records within a table. It empowers us to make changes to specific columns, updating the data as needed. Then delete. The delete statement enables us to remove unwanted records from a table. It's a powerful operation but requires caution to avoid accidental data loss. By mastering these data manipulation techniques, we gain control over the information stored in our databases. SQL's capability to add, modify, and delete data efficiently em- dat- data efficiently empowers us to maintain data accuracy, keep information up to date, and manage data effectively. These operations are vital for keeping databases relevant and useful in various applications, making SQL a fundamental language for data management tasks. SQL offers a rich set of functions that enhance its querying and data manipulation capabilities. Here are the key types of SQL functions. Common aggregate functions. Functions like count, sum, average, min, and max allow us to perform calculations on a set of values for For instance, count returns the number of rows in a group, while sum calculates the total of a numeric column. String then string functions. SQL provides functions for manipulating text data. Concat is for concatenating the strings. Substring extract a portion of string. The upper and lower convert text to uppercase and lowercase respectively. Date and time functions. SQL allows us to work with dates and times effectively. Date function extracts the date from a date time value. Date adds a specified interval to a date, and date diff calculates the difference between two dates. By leveraging these functions, we can conduct complex data analysis, performing calculations on data sets, and format information in various ways. Understanding and utilizing SQL functions and expanding our ability to extract valuable insights and make informed decisions based on the data stored in our databases. Data filtering is a crucial aspect of SQL that allows us to retrieve specific information from a database. SQL provides several methods for filtering data. Comparison operators. SQL uses comparison operators like equal to, or less than or greater than, not equal to, less than or equal to, greater than or equal to compare values in database. Then logical operators. SQL utilizes logical operators such as and, or, and not to create complex conditions for data retrieval. These operators help combine multiple criteria in a single query. In and between. The in operator allows us to specify a list of values, while the between operator defines a range of values. Both operators aid in filtering data based on multiple possibilities. By mastering data filtering techniques, we gain precise control over the data is what data is retrieved from the database. This filtering mechanism allows us to narrow down our results, ensure that we only obtain the relevant information needed for analysis, reporting, and decision making. SQL's ability to filter data efficiently makes it an indispensable tool for handling large data sets and extracting actionable insights. In SQL, joins are vital for combining data from multiple tables, providing comprehensive insights from interconnected information. Here are the key join types and their significance. Inner join. The most common type of join. Inner join returns only the matched rows between two tables based on a specified condition. It helps retrieve relevant data from related tables, ensuring data integrity. Left join or left outer join. Left join retrieves all the rows from the left table and matching rows from the right table. If no match is found, the result contains null values for the right table columns. It's useful when we want to see all records from the left table along with the related information from the right table if available. Right join, right outer join. Similar to left join, right join retrieves all rows from the right table and matching rows from the left table. It ensures that all records from the right table are included along with the related information from the left table. Understanding joins and establishing relationship using primary keys and foreign keys are crucial for navigating complex databases with multiple interconnected tables. These skills are invaluable for querying and analyzing data across various datasets and building a comprehensive understanding of the information stored in the database. In SQL, grouping and aggregating data allow us to derive meaningful insights from large data sets. Here's how these operations work. Group by class. The group by class is used to group rows with identical values in one or more columns. It enables us to categorize data into subsets based on specific attributes. Aggregation functions. Once data is grouped, we can apply aggregation functions like sum, count, average, min, and max to calculate summary values for each group. These functions provide valuable statistics about the grouped data. Having clause. The having clause allows us to filter grouped data based on specified conditions. It operates similarly to the where clause but on grouped data after aggregation. By leveraging grouping and aggregation, we gain insights into patterns and trends within our data. These operations are particularly valuable for creating reports, generating summaries, and performing analysis on data grouped by specific criteria. SQL's ability to group and aggregate data efficiently makes it a powerful tool for extracting valuable knowledge from database of all sizes. Subqueries, also known as nested select statements, are a powerful feature in SQL that enable us to use the result of one query as input for another. Here's how subqueries work and their significance. Definition: a subquery is a select statement embedded within another SQL statement such as select, update, or delete statement. Use cases: subqueries are valuable for complex filtering as they allow us to perform calculations or retrieve specific data before using the results in the main query. They are commonly employed in where and having clauses. Advantages: subqueries increase query flexibility and readability by breaking down complex tasks into smaller, more manageable steps. They also help avoid the need for temporary tables and make queries more efficient. By mastering subqueries, we can tackle intricate data retrieval tasks and perform more advanced analysis. Their ability to combine the results of multiple queries within a single operation significantly expands SQL's capabilities, making it a vital skill for data professionals and developers alike. Advanced SQL topics enhance our ability to work with the databases more efficiently and effectively. Here are some key areas worth exploring. First is indexes. Indexes improve query performance by creating a data structure that allows for faster data retrieval. Understanding how to create and use indexes optimally is crucial for handling large data sets. Views. Views are virtual tables that simplify complex queries and allow us to encapsulate frequently used queries into reusable objects. Mastering views enhances query readability and promotes code reusability. Stored procedures and functions. Stored procedures and functions are pre-written SQL code blocks that can be executed with a single command. They offer code modularity, security benefits, and reduced network traffic. By delving into these advanced SQL topics, we gain a deeper understanding of database management and optimization. Leveraging indexes, views, and stored procedures and functions can lead to more efficient and maintainable SQL code, empowering us to handle complex tasks and optimize database performance. Adhering to best practices in SQL ensures that we write efficient, secure, and maintainable code. Here are some key guidelines. Writing efficient queries. Optimize your queries to minimize resource usage and improve response times. Use indexes, limit the data retrieved, and avoid unnecessary calculations. Preventing SQL injection. Always use parameterized queries or prepared statements to prevent SQL injection attacks and protect your database from unauthorized access. Regular maintenance and backup. Perform regular database maintenance tasks such as optimizing tables, updating statistics, and taking backups to ensure data integrity and availability. Readability. Write SQL code that is easy to read and understand. Use meaningful aliases. Format code consistently and add comments when necessary. Test and validate. Always test your SQL queries thoroughly and validate results to ensure accuracy and correctness. Following these best practices ensures that your SQL code is robust, reliable, and optimized. By maintaining clean, secure, and well-performing databases, you will be better equipped to handle data-related challenges and make informed decisions based on accurate and trustworthy information. In conclusion, SQL or structured query language is an indispensable tool for interacting with the relational databases. Its ability to query, manipulate, and analyze data empowers data professionals, developers, and businesses in various ways. Efficient data retrieval. SQL's query Querying capabilities allows us to retrieve specific data from large databases quickly and accurately. Data manipulation. With SQL, we can add, modify, delete, and delete data, ensuring our databases stay up to date and relevant. Data analysis. SQL's aggregation grouping function enable us to gain valuable insights from our data, facilitating informed decision making. Database optimization. Understanding advanced SQL topics like indexes, views, and stored procedures helps improve database performance and maintainability. By applying best practices and mastering the various concepts and functions of SQL, we can harness the full potential of databases and leverage data as a strategic asset. SQL remains a fundamental and essential language in the world of data management, contributing significantly to the success of modern businesses and data driven initiatives.